47 years from home, Voyager 1 drifts beyond our solar system, its voice fading into the cosmic noise. Then, against all odds, a long silent system sparks back to life. This isn't just a repair, it's a last-minute rescue of humanity's farthest emissary, 15 billion miles away. What was broken? How did NASA pull it off from a full light day away? And why does this change everything we thought about the mission's final years? Stay with me because the answer is a high-stakes, one-shot gamble that could have ended in silence forever. Crisis at the Edge. Voyager 1 is the most distant human-made object ever built. Launched in 1977 and now traveling more than 15 billion miles, about 24 billion kilometers, from Earth. For decades, it's been our only active probe in interstellar space, still returning measurements of cosmic rays, plasma waves, and magnetic fields. But in early 2025, engineers faced a chilling reality. Its ability to keep pointing its high-gain antenna toward Earth was in jeopardy. The culprit was in the attitude control thrusters, responsible for tiny adjustments that keep the antenna locked onto our planet. Without precise orientation, Voyager 1's faint, 20-watt signal, already taking nearly 23 hours to reach Earth, would drift into the void, effectively cutting off all communication. The spacecraft's primary role thrusters were degrading, and the only viable replacements hadn't been fired since 2004. To make matters worse, time was running out. The Deep Space Network's 70-meter antenna in Canberra, Australia, the only dish powerful enough to send commands to Voyager 1, was scheduled for upgrades in May. That meant any attempt to restore thruster function had to be completed before the station went offline for weeks. Failure to act in time would mean losing command capability, possibly forever. The risk was clear. If the backup thrusters didn't work, there was no alternative. A misfire or complete non-response could have left Voyager 1 spinning uncontrollably, unable to correct its aim, and beyond help once the Canberra station shut down. This was more than a mechanical issue. It was a race against both physics and the clock. Every passing day brought Voyager 1 closer to a point where its final signal could simply vanish into space. The stakes? The survival of the longest-running, farthest-reaching mission in human history. NASA's engineers knew they had one chance to avert a silent end. The plan they devised was ambitious, risky, and would require precision worthy of the spacecraft's legendary legacy. We'll see how they aim to awaken a system untouched for over 2 decades without being able to touch it at all. The impossible plan. Restoring Voyager 1's backup thrusters wasn't a matter of just turning them on. These roll control thrusters, last used in 2004, had sat dormant for over 21 years. Their associated heaters, designed to warm the propellant lines, were likely inactive and possibly disabled by a faulty switch somewhere deep in the spacecraft's ancient electronics. NASA's Jet Propulsion Laboratory team began poring over decades-old schematics, written in the engineering language of the late 1970s. Many of the original designers had long since retired, and the commands for these systems were embedded in archaic code. Every action had to be perfectly calculated, because any mistake could trigger unintended behavior in a spacecraft operating in an environment where a single fault could be fatal. They suspected the problem lay in a heater circuit, critical for ensuring the thrusters could ignite without fuel lines freezing. But they couldn't just flip the heater on and hope for the best. A round trip is nearly 46 hours. That meant no real-time corrections. Every move was a high-stakes guess, followed by almost 2 days of tense waiting. Complicating matters was the looming May 4th, 2025 deadline, the date the Canberra antenna would go offline for maintenance. Without it, Earth wouldn't be able to send any new commands for weeks. The thrusters had to be revived before then, or risk losing the chance entirely. The JPL team crafted a single, complex command sequence to reroute control, warm the thruster lines, and attempt ignition. They knew it could fail silently, ignite erratically, or, if everything went right, restore Voyager's steering control just in time. They uploaded the command and began the wait. For nearly 2 days, all they could do was monitor faint carrier signals for signs that Voyager was still alive. Inside Mission Control, decades of engineering experience were on the line. Outside, the clock kept ticking toward the moment Earth's last physical link to Voyager 1 would temporarily vanish. And then, the data began to arrive. What it revealed would become one of the most remarkable comebacks in space exploration history. Miracle in the Void. The readout confirmed what few had dared to hope. The heaters had engaged, the propellant warmed, and after 21 years of silence, Voyager 1's backup thrusters fired successfully. In the cold, airless dark of interstellar space, 15 billion miles from home, systems once thought beyond recovery had answered the call. The effect was immediate. With functional roll control restored, Voyager could reorient its high-gain antenna precisely toward Earth. Its signal lock, which had been at risk of drifting beyond correction, was stabilized. Communications were secured for the foreseeable future. Engineers described the moment as glorious, the kind of technical victory that comes only once in a generation. But this triumph is not without limits. Voyager 1's radioisotope thermoelectric generators lose about 4 watts of power every year. In February 2025, NASA had already shut down its cosmic ray subsystem to save energy, and more instruments will inevitably follow. Even with the thruster revival, the mission's end is still in sight, likely in the early 2030s, when power drops too low to operate the remaining systems. The success, however, has bought precious years. Each extra year means more measurements of the interstellar medium, more time to observe cosmic ray patterns, and more chances to detect phenomena we've never seen before. Voyager 1's position, beyond the heliopause, where the sun's influence fades into interstellar space, makes it a one-of-a-kind observatory. For the NASA team, the emotional impact was profound. Many had dedicated decades to the mission, and some had worked on Voyager since its planetary flybys in the 1970s and 80s. To them, this wasn't just a machine. It was a companion that had traveled farther than any human dream had dared before. The thruster revival also speaks to the durability and adaptability of spacecraft engineering. Few designs are built to last nearly half a century, and fewer still can be coaxed back to life after decades of inactivity. This win proves that with ingenuity, patience, and calculated risk, even the most remote and aging systems can surprise us. Voyager 1 is still heading outward at over 38,000 miles per hour, carrying its golden record, our message to the stars. And now, thanks to a few tiny bursts of thrust, that message will keep playing just a little longer. Voyager 1's thruster revival is more than an engineering feat. It's a defiance of inevitability. Against extreme distance, aging hardware, and a relentless ticking clock, humanity kept its farthest explorer alive. The mission will end someday, but not today, and every extra day means more science, more history, and more connection to a probe that has carried our curiosity farther than anything else ever built. Thanks for watching. We'd love to hear your thoughts in the comments. If you enjoyed this video, don't forget to like, share, and subscribe. Your support means the world and keeps our journey going.